K-means clustering. K-means clustering is an unsupervised learning algorithm that partitions data into K clusters. Each cluster is defined by its centroid, and each data point is assigned to the nearest cluster. The algorithm iteratively adjusts centroids to minimize the variance with each cluster. Let's jump into the implementation where we will write the code and explain line by line for implementing k-means clustering in Python. So I'm going to go here. I already have the file ready, and I'm going to first do is import the necessary libraries, which is from sklearn cluster import k-means. Now this imports the k-means class from scikit-learn's cluster module. K-means is a clustering algorithm that partitions data into a specified number of clusters by iteratively updating centroids until the clusters stabilize. Next, we'll import the numpy as np, which imports the numpy library, which provides support for numerical operations and array manipulation in Python. Now let's get the sample data. Example, we'll get some points in 2D space, and that's what I have here, where x equal to np array defines the features data x as a numpy array where each sublist represents a data point in 2D space. Now each data point has two values, x and y coordinates. For example, 1, 2 and 10, 2 represent 2 points in the 2D plane. The shape of x is 6, 2, indicating 6 data points with 2 features each. Now let's go and initialize and fit the model. So initialize, I'll say k-means equal to k-means, n clusters equal to 2, random state equal to 42. Now this initializes a k-means clustering model with the following parameters of n clusters equal to 2. It specifies the data should be partitioned into 2 clusters, and random state 42 sets a random seed for reproducibility, ensuring the initial positions of the centroids are the same each time the code is run. Next, I'm going to say k-means fit x. Now fits the k-means model to the data x. During this process, the algorithm assigns data points to clusters by iteratively updating the positions of the centroids until convergence. Each point is assigned to the nearest centroid. Next, let's get the cluster centers and labels. To do that, I'm going to say centroids equal to k-means.cluster underscore centers underscore. Now this retrieves the coordinates of the cluster centers, which are the centroids, after training. Each centroid represents the mean position of the points within a cluster in 2D space. Next, I'll say labels equal to k-means.labels underscore. Now this retrieves the labels assigned to each data point in X, where each label represents the cluster 0 or 1 to which the point belongs. The labels allow you to see which points are grouped together. Next, let's go ahead and print the cluster centers, the centroids, and labels, which are the labels. And so this code kind of demonstrates how to use k-means clustering to group data points in 2D space into 2 clusters. After fitting the model, it outputs the centroids of each cluster and the assigned cluster labels for each data point, showing which points belong to which cluster. Let's run it and see. And there you go. We have our cluster centers 1, 2, and 10 and 2. And then the labels are 0, 0, 0 and 1, 1, 1. Here they are assigned exactly as we needed. So this is how you can implement k-means clustering algorithm using Python code. If you had any problems or issues, have any comments or questions, let me know and I'll get back to you.